Let's play this game. I can control these two servos left, right, forward and backward using this joystick. So let's learn how to program this project and build our own maze game using Arduino. To build this project we'll need some 3D parts like this base, the XY axis holder, the most important, this is the maze, and some holders to keep the servo steady. And the electronic parts are most important, the brain, Arduino UNO, a joystick to control servos, two servo motors, I am using SD90 servo over here, then a servo motor driver. Then we have a battery pack which is, we have two 3.7 volt batteries, and we have this buck converter and some screws, and most important is metal ball. So let's assemble our maze robot. First take the base, and we'll be using this Arduino UNO. Just slide it like this and fix the Arduino UNO over here properly. So the Arduino is fixed now. Then I will attach the cover to keep the Arduino steady. So I will use this cover like this, and I will fix one screw over here. So I have this screw. Just let's fix this with the screwdriver. So the Arduino is fixed now. Let's fix the joystick. So I'll keep the joystick over here, and I will add two screws in the diagonal like this, and let's tighten it. First we'll connect the servo motor driver with the Arduino. So first connect the ground pin to the ground of the Arduino like this. Then we have SCL pin. SCL pin will go here. This is the Arduino's SCL pin. Then we have SDA. This is a SDA pin. And we have the VCC. So I'll connect the VCC to 5 volt. So our connections are done. Now let's power this servo driver. So I have this 7.4 volt battery, but this servo driver needs 5 volt. So for that I will be using this buck converter which converts 7.4 to 5 volt. So first connect this with the servo motor driver. And another end of this buck converter will go to the battery's positive and negative terminal. And make sure that the battery should be off for now. And let's connect the positive and negative. This is done. Now before connecting the servo, now this is the servo motor. I will be connecting this to the channel 1 of the motor driver, and the colors are already mentioned, so we don't need to worry about. Simply I will connect the servo over here, and what I will do is first I will set this servo to 90 degree before installing the servo on the mount. So let's first write the code to rotate this servo to 90 degree. Similarly, I will follow the same step for the second servo. So let's connect the second servo to this, and so again I will rotate this servo to 90 degree before installing it on the maze robot. So this is the code which we are using to set both the servos as 90 degree. We have this 0, which means the channel 0 of our motor driver, servo motor driver, and 90 means a 90 degree angle will be set by the servo. So always remember that before installing the servo, make sure that it should be set to 90, so that it will be easy for you to calibrate your maze game. Alright, so this is the code. I will share the link of this code in the description. You can take it from there. Now let's connect this joystick with the Arduino. So first we'll connect the ground and 5 volt. So ground is connected to ground and 5 volt is connected to 3v3. Then we'll connect the x-axis. So the x-axis will connect to A0, analog 0, like this, okay, and then connect the y-axis. Then connect the y-axis to A1. Let's install the servo. This is the servo 1 which I'm using for x-axis. So I'll add the servo over here like this in the socket. So now let's first attach two servo mounts together like this, so that one will monitor the y-axis and one will monitor the x-axis. For that we have some screws. So this is fixed. Now let's attach it on the servo. So first mount the servo over here, and then we will fix this like this, or first I will mount the servo over here like this. Now let's fix the servo and make sure that servo is set to 90 degree. And use the second servo to fix over here like this. And then we'll place the servos over here. Now we will place this maze, but before that we will add this maze. We will mount the maze holder over here. For that I will be using 2 screws in the diagonal. And then mount this maze over here like this. So the maze assembly and the connections are ready. You will see it. Okay, so the connections are ready, but we need to calibrate this. As you can see, the maze is not properly aligned. We'll place this ball on the starting position, and let's calibrate this maze first by the programming, and then we'll play this game. Let's understand the code that control our maze game. The joystick is used to control the servo motor using PCA 9685 servo driver. First, we include the wire library, which help us to communicate with the servo motor driver using an I2C communication. Then we include the Adafruit servo library, which make it easier to control the PCA 9685. Here I created the PWM driver object that can set the address to 0x40, which is the default address of the PC motor driver. Next, we define the 2 joystick pins. The X is connected to A0, analog 0, and Y is connected to A1. The Arduino will continuously read 2 analog values to understand how the joystick is being moved. Now we define the servo channels. Servo channel 0, which control the X-axis, and servo channel 1, which control the Y-axis. These 2 values are very important because the physical center of the maze is not exactly at 90 degree. For my setup, the X servo is centered at 105 degree, and for Y servo is centered at 97 degree. So whenever the joystick is released, the maze will return to the calibrated center position. In your case, you may need to calibrate your servo, and this angle will be different for you. Next, we define the minimum and maximum angle for each servo. X can be moved between 30 to 140 degree. Y can be moved between 70 to 150 degree. These limits are important because they prevent the servo from moving beyond the safe mechanical range of the maze. Here we create 2 types of values. X angle and Y angle represent the current servo position, and X target angle and Y target angle represent where we want to move the servo. This separation is useful because instead of immediately jumping to the target angle, we can smoothly move the servo towards it. A joystick normally gives a value in between 512 when it is on center position, but the joystick not stay exactly at 512, it might fluctuate slightly. To prevent these small fluctuations from moving the maze, we created a dead zone of 70. So if the joystick value is close enough to its center position, the code treat it as if the joystick is still centered. This value controls how smoothly the servo moves towards the target. Basically, this is the angle. This is the angle which we are adding to tilt the servo left, right, or forward, backward. The servo driver needs a PWM value, so this function converts a servo angle from 0 to 180 degree into a PWM range that we want to send to the servo. In this setup, the pulse range is from 170 to 570. This allows us to control the servo position using normal angle values in the rest of our program. Then we have the setup function. Here we are setting the baud rate to 9600. Then we are initializing the motor driver, servo motor driver, and we are setting the frequency to 50 Hz, which is the default frequency of our servo. Now we are setting the servos to the center position that we have calibrated. So here we are passing the center position of the servo. Then we have added the delay, a small delay. After that, we are reading the X and Y value of the joystick, and we are printing it for the very first time. Then we have the main logic. Here in the loop, we are again reading the X and Y position of the servo. In my case, I have swapped the servo joystick So the X joystick control will control the Y servo, Y control the X servo. This is because the two control left right, forward backward motions of your servo. Alright, this is where the joystick actually start controlling the maze. Notice that the X joystick control the Y servo. First, the code checks whether the joystick is inside the dead zone. If it is, the target position is set back to center. Otherwise, the joystick value from 0 to 1023 is converted into Y servo angle using the map function. Similarly, for Y, we are doing the same thing here. We are controlling the Y value, controlling the X servo, X axis servo here. Then this is the important thing. After calculating the target angle, I use the constraint function. This makes sure that the target angle can never go outside the minimum and maximum value that we defined earlier. So even if the joystick gives an extreme value, the servo will remain within its safe range. And then we are moving the servo using this formula. Now comes the part that makes the movement smooth. Instead of directly setting the servo to the target angle, we calculate the difference between the current angle and the target angle. Then we move only a small portion of the distance using smooth amount, which we have defined earlier. This is why the maze doesn't suddenly jump from the one position to another. It smoothly follows the joystick. Again, this is a very important portion. When the servo gets very close to the target, there can be tiny differences caused by the floating point calculation. So if the difference is less than 1 degree, we simply set current angle equal to the target range. This helps the servo settle properly instead of continuously making a small movement. Finally, we convert our calculated servo position into integer values. Before sending them to the PCA9685, the code checks whether the angle has actually changed. If the angle has changed, then only we send the new PWM values to the servo. This avoids unnecessary sending the same position repeatedly. And finally, we are printing the values. These values are very important to print because this helps us to calibrate your maze game. And this is all in this code.